because it's quite long-winded. All the Eurocodes you'll find have this designation EN and then 199. The number at the end of the 199 is then the actual Eurocode itself. So EN 1992 is Eurocode 2, and the -2 just means it's Part 2 of Eurocode 2 Part 2. So if I'm trying to reference clause 3.1 of Eurocode 2 Part 2, that's a lot to write out. And so you'll find that the abbreviation used everywhere is this one here. It's 2.2 for Eurocode 2 Part 2, and then /3.1 means clause 3.1. Every formula in the Eurocodes has a unique expression number, which is always in the Eurocodes given in brackets. So if you see expression 3.1 there in brackets of Eurocode 2 Part 2, again that would be abbreviated as 22/ brackets 3.1 shorthand. Figures are done in the same way. Finally, if you see in the slides, or again if you print out the detailed notes at some later time, if you see an expression that's got a D in front of it, that means it's not in the Eurocode, it's only in the detailed notes or in those books. And what that's been put in there for is sometimes the Eurocodes just have principles. It's telling you to do something, but it doesn't give you a formula to do it. So we've tried to be helpful in a number of places and provide a formula that complies with that principle for you. So if you see a D, it will comply with the Eurocodes, but it's not in the Eurocode. Right, so that's a sort of general intro to how the notes talk to each other. In terms of getting us sort of started with the introduction to the Eurocodes themselves, just start here with a quote from a document that was put together by the Institution of Structural Engineers for Government in April 2004. And this was a national strategy document, and it was aimed at trying to lever out some money from government to help industry implement the Eurocodes. And it didn't work, we didn't get any money from government, but it did serve as a useful assessment of the impact of Eurocodes on the UK. And two of the introductory quotes taken from that document are up on the screen there. The first one says that the structural Eurocodes are a European suite of codes, structural design developed over 25 years. So bearing in mind that's now 6 years old, they've been coming for 30 odd years. So a lot of research, a lot of work has gone into getting these codes up to date, and they are up to date. And they're widely regarded as the most up-to-date suite of codes in the world. I think that's fact. The second quote is by 2010, specifically 1st of April 2010, so we're beyond that date now, they will have effectively replaced the current British standards as the primary basis for designing buildings and civil engineering structures in the UK. So the two important things are, they're here. But secondly, that is the scope. They are intended for buildings and civil engineering works. So some things are outside the scope of the Eurocodes. For example, nuclear reactors and containments aren't explicitly covered by the Eurocodes because it doesn't have load combinations, loads for nuclear containments. That said, the latest generation of European pressurised water reactors are being designed effectively to Eurocode 2 with some additional load cases in there. So although they're not within the scope, they can be used for that sort of structure. This little diagram just shows really all the countries that are directly influenced by the Eurocodes. In 2002, the darker blue countries there signed up with CEN to implement Eurocodes in place of their national standards. And all of those dark blue countries have had a very major part in inputting to the design rules in the Eurocodes, and they've had voting rights, so they've had a say as to what goes into the rules. The lighter blue countries, or the intermediate countries here, joined a couple of years later or signed up a couple of years later, and they've also had a very strong input into the codes. They have voting rights again, so they've had an influence in what's actually gone into the codes. And the way the voting system has worked, and I won't go into exactly how it works, but the way it's been put together is that if either England, France or Germany didn't like a rule, they could always vote it out. Other countries would have to be in a sort of majority if they didn't like something. So those three countries were in a more fortunate position, if you like, if they really didn't like a rule. And then finally we've got the lighter blue countries, affiliates like Turkey. These are countries which are signed up to use the Eurocodes, but they haven't had any input at all into drafting. So they've just basically taken the Eurocodes and they get what they're given, basically. So these are all the countries that are directly influenced and have to use the Eurocodes. But we are increasingly seeing other countries going towards implementing Eurocodes as well that are outside Europe. And these are generally the countries that have had a historical dependency on British standards. So countries like Malaysia, Singapore, they've signed up definitely to implement the Eurocodes. Hong Kong are looking very strongly at implementing the Eurocodes. And then other countries have already started. South Africa, for example, has changed all its standards to suit Eurocodes. But some of it's adopted the Eurocodes and some of it's adapted the Eurocodes. So occasionally they've sort of taken the Eurocodes and decided they don't like little bits of it and changed it. That probably is not so advantageous really, because we potentially end up with slightly different versions. India are doing the same thing at the moment. They're looking at the whole suite. So it could become a global code actually quite quickly. Absolute basics. There are 10 structural Eurocodes set out here. We have Eurocode Naught is the head Eurocode, basis of structural design, and it is an important document because it sets out requirements for load combinations, it sets out definitions of actions, definitions of what you're trying to achieve with each limit state. So you need that regardless of what material you're designing in. Eurocode 1, also important regardless of which structure, which type of material you're designing with, because it covers actions. That's the first piece of Eurospeak. Actions just basically means loadings. And then the common ones, or most common material parts, are Eurocodes 2, 3 and 4, which we'll be covering over the next few days. But we've also got other parts. So there's a part for timber, part for masonry. Eurocode 7 we won't really be covering at all over the next 4 days. But there is a fairly significant change in geotechnical design because it moves over to ultimate limit state like all the other suite of Eurocodes, so it's fully compatible with concrete and steel. We've also got Eurocode 8 for earthquake seismic. That doesn't have a great deal of relevance to the UK, but it would obviously be relevant if you're working outside the UK in seismic areas. Eurocode 9 covers aluminium alloys. There is a Eurocode 10 in the middle of being drafted. I think it's suffered because of the recession. There's no money. But Eurocode 10 will be covering structural glass. I don't know what time that will ever appear, but it is there in the pipeline. So this is just a bit more detail. Although there are 10 Eurocodes, there are in total 58 Eurocode parts because each of those Eurocodes subdivides into other parts. And the next two slides isn't the entire list. It's about 20 or so. But it shows you how many Eurocode parts you might actually need to do a design, in this particular case steel concrete composite. It's quite a lot of parts. So for example, you will always need Eurocode Naught, as I mentioned, and it's equivalent in scope to BS500 Part 1 and a bit of Part 2 because it sets the general requirements. Eurocode 1, there are 10 parts, of which in the UK typically we'd need 8 of those. And the scope of those is pretty much the same as Eurocode BS500 Part 2, but the material that goes in there goes in quite a lot more detail. Some of it's useful, some of it's less useful. So for example, the wind code covers everything we had previously on quasi-static gust pressures, but it also covers a lot on bridge aerodynamics, which you used to have to go fishing around in Highways Agency documents or other places. So that's quite useful to have that together in one place. Other bits are less useful. So for example, Eurocode 1 Part 1.1, densities, self-weight and imposed loads, has a very long annex that runs about 20 pages. And in that annex, it covers things like angles of friction and densities for piles of fruit and vegetables and wet and dry manure and all sorts of things that I've never used in a design. But if you want to know that sort of information about what angle a pile of apples will topple, that's in Eurocode 1.1. Then we go on to material parts. So Eurocode 2, the most important thing here really is that the general rules that you use, regardless of what type of structure you're designing, are in Eurocode 2 Part 1.1 called General Rules and Rules for Buildings. So that actually is covering bridges to an extent as well. And the bridges part, Eurocode 2 Part 2, only makes bridge-specific additions or modifications. So it's a much shorter document. In fact, I'll be handing these out later on. That's the general rules and rules for buildings, that sort of thickness, and that's the bridges part. Eurocode 3 is structured in a similar sort of way. So again, if you're designing any sort of steel structure, then you basically start really with the general rules and rules for buildings, because that contains all your rules for overall design, buckling, bending, shear. The bridges part, again, is a shorter document and is a bolt-on, again, just making bridge-specific modifications and additions. So, for example, there are some rules which relate to box girders in Eurocode 3 Part 2, because generally buildings people don't design box girders. But then regardless of what type of structure you're designing, there are quite a lot of parts of Eurocode 3, and you will need other bits. So, for example, if you've got a stiffener, bearing stiffener or transverse stiffener, then you will need Eurocode 3 Part 1.5, plated structural elements. And if you've got a bolt or a weld, as clearly you're going to, in a steel bridge design, then you'll need Part 318 for the design of joints. So things that used to be together in BS 500 Part 3 have been separated out into different codes, and that's really historical because of the different project teams that were established to draft in each of these areas. Finally, Eurocode 4. Again, there are two parts. There's Eurocode 4 Part 1.1, General Rules and Rules for Buildings, and Eurocode 4 Part 2. This is the only exception whereby the bridges part actually reproduces all of the general rules. So in fact, for steel composite, you do not need Eurocode 4 Part 1.1 because everything has been reproduced in Eurocode 4 Part 2. Sen gave the Eurocode 4 project team a special dispensation, which they didn't give to any other project teams to do that. And that was really because Eurocode 4 Part 2, in its first incarnation, which was a bolt-on, was impossible to use, really. There were too many cross-references because it had to cross-reference to the loading parts, to Eurocode 2, to Eurocode 3, to the other part of Eurocode 4, and I think there was one cross-reference which did it, or one clause rather, which contained, I think, 6 cross-references, and it was just unreadable. And so the decision was made to separate that part out, and I think that was a good decision, and in many ways it's a shame that actually we didn't do that with the other Eurocodes, because it's a much easier document to read without having to flick to another one to see what's changed. But again, having said all that, it's really just equivalent to BS 500 Part 5, and you'll find Eurocode 4 Part 2 in particular does look very similar to BS 500 Part 5 because the project team convener for Eurocode 4 also wrote BS 500 Part 5. I should say, actually, we're the only country, the UK was the only country that had a delegate on every single Eurocode part. And therefore, although the Eurocodes you'll find do look different to British standards, they look a lot more similar, I think, to British standards than they do to any other national standard. So we've actually done quite well out of it. This is now really just a bit of history as to when the Eurocodes came out. It's just a map showing when the parts were actually published by Sen. So these are the ENs, not the BS ENs. But the text hasn't changed since when the EN came out. All that happens when the BS comes out is that BSI put BS in front of it. That is literally all that happens. So you can actually see here that Eurocode 0 was actually published, dark blue, it was actually published back in 2002, so it's been around a hell of a long time. And the last Eurocode part itself was published back in 2006. So BSI and the various BSI committees have actually taken quite a long time to get the national annexes in place, given when these codes actually came out and were finally published. And the national annex is important because, in theory, you can't really do any design without the national annexes. And each member state, the standards body in that country has the responsibility of producing the national annex. So in the UK it's BSI, in Germany it would be DIN, AFNOR in France, for example. And the national annex is supposed to be a very, very short document, and there is very limited stuff which is supposed to be able to go into that national annex. And generally it's limited to things called nationally determined parameters, which are things like material factors. So the Eurocode will give a recommended value for a material factor, for example, and each member state can change that value if they want to.
Which one is superior then? The national annex parameters are superior to recommended value?
The national annex parameters are superior, yes, and you have to use, whichever country you're working in, wherever the project actually is, sorry, not where you're working, wherever the project is, you have to use the national annex of that country. If a country does not have a national annex, then you have to use the recommended values, basically. But I don't think there are any countries that haven't got a national annex. It may be that they have a national annex and it just says use the recommended parameters, but they still have a national annex. So they've actually made that decision consciously. The other thing that goes in under NDPs tends to be things which are very country specific, like climate. So your wind map, for example, or your isotherms will go in your national annex. There will be decisions on traffic as well, traffic loading, because that's country specific. The only other thing I think that can go into a national annex is something called NCCI, which is non-contradictory complementary information, or at least references to it, and that's just stuff which the country thinks will help you in your design. So it might be references to textbooks. For example, those Thomas Telford books are actually cited as NCCI in some of the national annexes, but they don't really have any status as such. So compliance with a piece of cited reference doesn't really carry any proper weight, although there must be some sort of status attached to the fact that it's been mentioned in a BS document, but to be honest, we're not actually sure what status it has. There is an intention, although I think we're probably a long way off this, that national annexes will eventually disappear. Clearly the ones that have wind maps and things can't, but things to do with steel and resistances, the intention is that they will disappear, because there is no reason why a piece of steel in the UK should have a different gamma M value to a piece of steel in France. So the intention is to get rid of those long term. And the national annexes have only really been a mechanism to get people to agree on the Eurocodes and get them out finally being used. So we've been under pressure, each member state's been under pressure from CEN to try and keep national annexes and recommended values as close as possible to the Eurocodes, because it will just be a much bigger job to get consensus later on if everybody's changed all the recommended values. And we haven't had too much trouble in doing that, to be honest, in the UK. There has been calibration exercises done, and generally we've managed to accept the recommended factors. Either, there tends to be two things. Either you get reasonable agreement with the old practice, in which case you can accept the recommended values, or you get quite a lot of economic benefit. And what we haven't tried to do is reduce the benefit back down to what it was before, if that benefit is fully justified by a better understanding of the behaviour and more testing. So quite often where resistances have increased, they've come under a lot of scrutiny, and we've just accepted that they should be bigger than they were before. An important thing is that now that the Eurocodes have come in, anything that's funded with public money has to be at least offered for design to Eurocodes. So clients have to put their tender documentation out using Eurocodes. They can accept other standards if you propose other standards, but it's very unlikely that anyone's going to accept other standards if you propose an old code, because if anything goes wrong, all parties are potentially in some trouble, because if it ever goes to court, the first thing that the court proceedings would establish is that we were all using a superseded standard. Even if there's nothing wrong with that standard, those are just the facts. It's a withdrawn standard, so you're not starting in a very good position. So although there is that potential to use old standards, the withdrawn standards, I don't think it's going to be very popular. And certainly our major clients like the Highways Agency are driving forwards and are insisting now on using Eurocodes. So again, this is just historical really. This is a map of when the UK national annexes rolled out, but basically they are all here. So we can crack on doing designs to Eurocodes in the UK. This slide shows what should have happened in terms of preparing us for Eurocodes, but it didn't really. There was supposed to be, working back from the March 2010 deadline, there was supposed to be a 3-year period back to 2007 when all of the Eurocodes would have been published by CEN, and in fact CEN did actually meet that deadline. And then in the 3 years after that, there should have been a period of coexistence whereby clients could choose whether they wanted to use the Eurocodes or the British standards, and the intention was that clients would choose some projects to use the Eurocodes so we could all practice and try them out, and we wouldn't end up with the situation we have now where everybody picks up the Eurocodes in April and suddenly we all find the problems together. So we haven't achieved the intention, and the real reason for that is if we go back beyond the 3 years, we should have had all the national annexes prepared 3 years ago, and that just did not happen. It was much more complicated and difficult than everyone thought. So the national annex preparation period basically ate into that coexistence period, and it didn't happen. One other thing to say about the whole Eurocodes suite is that the Eurocodes, when people talk about Eurocodes strictly, they are only the N199 series. But there are a lot of other Euronorms that go with the Eurocodes. And the Euronorms basically split into either product standards, such as the one here, EN 10025, which covers the specification for steel plates. Or it splits into workmanship standards, for example, the N1090 Part 2, which is the fabrication standard for steel work, which is equivalent to BS500 Part 6. So these are Euronorms. They are not Eurocodes. It's a bit pedantic, but some people call anything with an EN the Eurocode. They're not. They're Euronorms. And it's only the N199 series, which are actually Eurocodes. And it's very important that you follow... Sorry, it's going to drive me mental if it keeps doing that. It's very important that you do use the Eurocodes with the Euronorms. So we can't mix old product standards, for example, because a lot of the increased resistances that come in the Eurocodes are there because of modern fabrication and modern materials. And this is one of the dangers of trying to apply Eurocodes for assessment. We can talk about that later on, but Eurocodes specifically do not cover assessment because the rules do not necessarily work with old materials. But that actually doesn't mean that you can't use the Eurocodes for assessment if you know what you're doing and you understand the old materials. So what are the impacts for designers? Well, first of all, with all those countries that have been inputting into the Eurocodes, you won't be surprised to find that there hasn't been any consensus across Europe about the sort of general scope or the content of the Eurocodes. And in fact, we've had quite opposing views. So, for example, in the UK, the suite of codes we had before have been very prescriptive, as we've all seen. There tends to be a rule and a formula in for every scenario, even if it's completely inappropriate to use the formula for that scenario because it's been derived for something much simpler than you're trying to apply it to, but that's just the way we've been. And there's a lot in the UK wanted that to continue, very, very prescriptive rules. If you go further sort of south, and it seems to be the further south you go, the more relaxed the engineers and the clients become. So, for example, in Italy, they just wanted sort of really high-level principles, almost like design the structure not to fall down. And the engineers should be able to get on and use their brains and their training to be able to comply with those principles. And what we've got is neither of those two extremes. We've got something in between the two. So it does mean there is a bit of cultural change for us here. And really that breaks down to using first principles a bit more perhaps than we've done before, which could mean anything. It could mean textbooks. It could mean greater use of fine element modelling sometimes. And it also means, I'll put the better knowledge of mathematics. It's not because you have to do lots of hard sums all the time, but you'll find the presentation of the Eurocodes is much more mathematical. And there's a classic example coming up with the load combinations next. Often they've used mathematics to explain things simply because mathematics is less ambiguous than words, particularly when they've had to be translated into other languages. Some people say that Eurocodes are loosely worded. That's just a lack of experience with the Eurocodes, and it comes back to the cultural change again, in that because things are often principle-based and it doesn't tell you precisely what to do, people say that it's loosely worded. It's not. It's quite precise, but you need to have a good understanding of how to comply with that principle. People also complain that the clauses are scattered around, which is understandable if you've got 58 parts, but actually they're rather well grouped together, the clauses. They're not scattered randomly. I find something like BS500 Part 3 much more scattered. You need lots of fingers to fit in all the pages. You'll find the Eurocodes are all written in the same way. So if you pick up a Eurocode, you'll find that sort of Section 1 is sort of the scope, Section 2 is the base of design, Section 3 will be materials, Section 4 will be durability, 5 will be global analysis, 6 will be ultimate limit states, 7 will be and they're all written in the same way. So when you pick them up, if you're trying to look for something, you immediately go at least to the right chapter in there. So they're quite good in that respect. I think the main driver for using the Eurocodes, which is a driver for those outside Europe, apart from the dependency on British standards, the driver is that they do give greater scope for innovation because they are less prescriptive and they do bring greater economy. because it allows you to do things that we weren't allowed to do before, more advanced analysis, for example, but the rules themselves are often much more economic because they're based on more recent testing. You do need to learn a few words, but it isn't really very difficult to do so. We've already heard what action means. It's a force or imposed displacement. Sometimes they're very long-looking words, like verification instead of check. That probably comes from the French verification. And you might ask, well, why not check? Well, this is another case of ambiguity, because the word check was used in places to begin with, and across Europe people didn't know what it meant. Because when we talk about checking a piece of work, it might mean actually get another engineer to come and check your work. Or it might mean that you yourself as the designer are just checking whether it works in bending. So even that very simple example led to confusion. So in the Eurocodes you won't see sort of check bending, you'll see something like perform a verification of bending. And then it's long-winded but clear, apparently. And the same is true with most of these words. They have very precise meanings to enable the drafting, because everything was drafted in English. Regardless of what nationality the convener of the project team was, everything was drafted in English and then has to be translated into other languages. So it must mean the same if it's translated into another language. So for example, a word like resistance, you'll now hear shear resistance or bending resistance, not shear capacity or bending capacity. The word resistance is used for matters relating to strength. There is a word capacity, but it's used for matters relating to deflection or deformation. So you'll talk about the slip capacity of an expansion joint or the movement capacity of an expansion joint. Clearly it doesn't really matter. If we say shear capacity and bending capacity, we all know what we mean, but you just won't see it written down in the Eurocode anyway. And then we've got words like execution. That's the new word for construction or fabrication. Isostatic, that means primary. And then there's a whole load of terms which relate to load combinations, which we'll go into in the next session. Some of the change is actually quite helpful. So you'll find the notation that's now used in the Eurocodes matches the notation that's used in virtually all software packages. So the XX axis in the Eurocodes is along the axis of the member. So IXX is no longer the major axis bending inertia. It's always something to do with torsion. So it fits with software packages. You'll also find over the next few days that the Eurocodes use subscripts a lot. And you just have to get to like them. It's a bit like learning a language again. They do enable you to work out what something means with a bit of practice. So I mean, a simple example here, ED is used as a subscript for the design internal effect. Basically means effect design in a member. So if you see NED, that's the design axial force within a member. And similarly, RD stands for resistance design. So if you see NRD, it's the design resistance to axial force. We'll pick this up as we go through, but basically the word D, design, the significance of that means it's been factored by load factors. So if it's a design axial force, the D means it's been factored by the gamma, the loading gamma factor. If you see a design resistance, then it basically has been divided by a material resistance. You'll also see K as well. Sometimes there might be NEK or NRK. A K is basically a characteristic resistance, which means it hasn't yet been factored by a gamma factor. That's the distinction. We'll talk more about that. So it can be helpful, can be unhelpful. The example at the bottom of the page shows a bit of an extreme case, AC, F, lock. That's something which features in Eurocode 3 part 1.5 for plated structures. And you can't shorten that by knocking the lock off the end, because there already is an AC, F, which means something else. So that's a very, very extreme case, but you do need to follow the conventions, otherwise you'll mislead people or get things wrong, particularly in spreadsheets. So we're nearly there on this section. The last things I want to say, really, very important in the Eurocode is the distinction between principles and application rules. A principle basically is a general statement or definition for which there is no alternative. So you basically have to do it. And you can spot them in the code one of two ways. The clauses themselves are marked with a capital P, like that one there, clause 3.1, paragraph 1P. That means it's a principle. And all principles should be marked in that way, but there are still some typos basically in the Eurocodes, and there may be some P's missing. in some places, possibly. So the other way you can spot a principle is the verb used is shall, a very high degree of compulsion. You shall do this. It's the same sort of system that the Highways Agency did with all their BDs, changing the shoulds in the BSs to shalls in their BD. You've got no choice, you've got to do it. Usually following a principle, there is an application rule. And the application rule is one means of complying with that principle. And they are generally industry accepted ways of complying. And the verbs that you see there have less compulsion. It'd be, you should do this, you may do this, you can do this. But there's otherwise no marking of the clause. So if there's nothing there, it's just based on an application rule. There's no capital A or anything for application rule. In theory, you can do alternatives to the application rules if, and sort of basically quoting from Eurocode Naught, it's if what you do provides equivalent structural safety, serviceability and durability or better. Clearly that would be almost impossible to prove. I wouldn't want to be demonstrating or trying to prove that to an expert witness. I'm sure you could, but it would best not. So if there's an application rule, what I suggest is you either use it, or if you don't like the application rule, you want to do something more sophisticated, use a more sophisticated computer model that complies with another application rule. So if you don't like the rules, for example, on columns, for buckling of columns and the extra moments, then don't make up your own rule, do a nonlinear analysis instead, which is covered by the Eurocodes. Last thing to say is that principal application rules only work if you satisfy these general assumptions which are in Eurocode Naught. And these are interesting because they basically underpin any code of practice, but I think it's the first time they've actually explicitly been written down in a code of practice. So some lawyers have been, with nothing better to do with their time, have been wondering what that does, whether that changes anything in terms of significance of the code and duties of clients, for example. And the assumptions are all pretty obvious, to be honest, and not that helpful either, really. So we've got, for example, the Eurocode design only works if you have appropriately qualified and experienced personnel choosing the structural system and designing the structure, but it doesn't define what appropriate means. So we don't know, again, until you end up in court, you find out whether you were appropriate or not. Yeah. Personnel with appropriate skill and experience execute the work. So that's basically the contractors know what they're doing. Execution is adequately supervised and quality controlled. I mentioned already that the construction materials and the products are used follow the specifications in the Eurocodes. That's very important as well. I always point this one out to clients. The structure is adequately maintained. Just because the structure has a 120-year design life doesn't mean it will last 120 years without maintenance. It obviously doesn't. So clients have to maintain structures. And then again, very obviously, the design only works if the structure is used in accordance with the design assumptions. So it's no good designing a footbridge for footbridge loading and then trying to drive a lorry across it, because it isn't going to work. So just to finish off this session, again, jumping back to the iStructE document, a couple of quotes, and bear in mind these were pessimistic because they were trying to get funding out of the government, but there is a lot of truth in them. They're a bit pessimistic, but there is some truth. The construction industry has not previously faced the challenge of implementing a complete suite of new codes encompassing all the major materials and loading requirements. Well, that's quite true. We haven't tried to whip all of the standards away before and bring in a complete new set. In the 70s, it was a much more difficult situation, I would imagine, with moving from working stress to ultimate limit state and changing the units from imperial to metric. But they didn't whip the whole suite of codes away, concrete, steel, timber, all the lot in one go. So it's slightly different. And then it says the burden will not be eased by the format and terminology of the Eurocodes, both of which are different from British standards. So you've already seen a taster of that. They are different. But I do maintain we've probably got off lightly compared to the rest of Europe. There's a lot more similarity for us. So there are some challenges. And if you are new to Eurocodes, as I'm sure many of you are, please do not be very depressed at the end of 4 days when you're not an expert in using the Eurocodes, because you won't be, I'm afraid. But you will have had some grounding, and hopefully when you actually start doing it in your own time on a real project, then some of this will come back and some of the clauses will actually make sense in a way that they wouldn't have made sense if we weren't sitting here. Things like the loading is a classic example. It takes weeks to figure out the loading and the load combinations if you come at it completely cold without somebody trying to explain it to you.